Our IWCS webinar series event is hosted by the International Cable and Connectivity Symposium. I am Ed Fenton, a cable industry advisor working with the IWCS team. As Connie said, if you have questions, please use the Q&A box on the bottom right of your screen to post a question anonymously. If you wish to contact the presenter or IWCS after the presentation, you will be given the contact points at the end of the webinar. Today, we are pleased to welcome Anthony Tassone, Principal Engineer at Underwriters Labs in Melville, New York, who will be presenting his paper on UL standard revisions and proposals, tri-national harmonization activities, and new service offerings. This paper was originally presented at the IWCS 2015 conference in Atlanta, Georgia, during session 15. You can find this paper 15-2 on the archives page at the IWCS.org website. Anthony Tassone is a principal engineer with UL in the wire and cable industry. He works primarily with the telecommunications cable categories and has also been the principal engineer for the seasonal lighting categories for over 20 years. Previously, he was a member of the Conformity Assessment Services section at UL, working on a variety of categories for almost 31 years. Anthony has a Bachelor of Science degree in Electrical Engineering from Polytechnic University and is a New York State professional engineer. Anthony, we're pleased to welcome you to present this IWCS webinar series event.
Well, thank you, Ed, and thank you for all those that are attending our webinar today on the UL standards revisions, proposals, tri-national standards, activities, and new service offerings. Just like this person shown in the picture, we are all wire people, and sometimes it feels like working in wire and cable can be an uphill battle. Today, we will discuss revisions and changes to the UL standards that may give us more opportunities to expand our markets and allow us to change the ways our products are tested. Our agenda for today is discussing the standards writing and development, revisions to UL standards and outlines, revisions to harmonize standards, and some updates on materials and compounds. Standards writing and development. To those who are not familiar, this can seem like a large task. But UL standards, the majority of UL standards are ANCE standards. That's the American National Standards Institute standards. And these are consensus documents that are handled by standard technical panels to UL's collaborative standards development system that we refer to as CSDS. The CSDS system provides online access for review and submitting information for UL standards development process. Anyone can make a proposal to a particular standard through CSDS, and in addition, can make comments on proposals that are described on CSDS. Only STP members can vote on proposals, but anyone can make comments. UL is also involved in the development of standards harmonized under CANENA. This involved manufacturers and standards development organizations from at least 2 of the 3 North American countries. We're constantly revising UL standards as technology has changed, and here are just some categories or some standards that have been revised. UL 1650, which is the portable power cable standard, was an outline of investigation, and it was recently converted to a UL standard in January 28 of 2015. In the process of being changed from an outline to a standard, an optional FT5 flame rating was added to the outline. The category, the UL CCN, is QPMU for those interested, and you can find that on UL's online certification directory. UL 1569, the standard for metal clad cables, Most people refer to these as MC cables. And the fourth edition was published in November of 2015. The revisions included expanding the AWG size for stranded conductors permitted to be butt spliced. Previously, the largest conductor was 10, and now the largest conductor is 8 gauge that is permitted to be butt spliced. A corrugated stainless steel armor was added to the list of armors that were permitted in the standard, and an optional binder jacket was also added. A certification requirement decision, which we refer to as a CRD later in this presentation, dated January 28, 2015, combines the power lighting circuits and Class 2 or Class 3 control circuits in the same cable. The wording of the National Electrical Code, Article 725.136, does not require Class 1 power and lighting circuit conductors to be separated from Class 2 and Class 3 if these Class 2 and Class 3 circuit conductors are in a non-metallic sheeted cable. The wording of the NEC Article 725.136 allows Class 1 power and lighting circuits to be separated from Class 2 and Class 3 circuits conductors by flexible tubing. This proposal adds requirements for construction of type MC cable that contains both power and or lighting conductors, as well as control and or single conductors that employ an inner jacket of the same thickness of non-metallic sheeted cables, also known as NM cables. A new section 9.4 was added to 1569 to include this inner jacket. Surface and tag markings are also being added to differentiate this cable from other MC cables. UL 2592. This was also a standard that was converted from an outliner investigation to a standard. This is for low voltage LED wire. It was issued March 9th, 2015, and it contains single conductor and multi-conductor unjacketed cables from 18 gauge to 10 gauge, from temperature ratings from 105 to 250 degrees C, 300 or 600 volts, and for use in dry and damp or wet locations. They're primarily used for signs, outline lighting, and interior lighting, and are connected to the output of the driver of an LED array. And the driver is a power supply for the LED lamps in these signs. It's only accessible during user servicing of the sign and is not required to be enclosed by an overall sign enclosure. The sign industry is very concerned about the size of these signs because some of these are somewhat large, and if there are live parts in the sign, then you would have to have an enclosure that is suitably flame rated and meet all the enclosure requirements. But if all the internal wiring is insulated, you do not need to have an overall sign enclosure. This is similar to GTO cable that was previously used in neon signs. But LED signs, as anything else that's illuminated by LEDs, is becoming much more popular these days for the power, the lack of power consumption, and it's very desired in the industry. So optional ratings were added to allow low voltage LED wire to be used outside the sign enclosure in areas of the building structure. This made it simpler for installations where you could use one cable to go from your power supply all the way into your sign. These cables are required to be FT4 rated and also have crush and impact ratings for the extended rating. This EX is very similar to ER ratings for other cables, but since it's a different wire type, we use a different rating for the extended run. UL 13, which previously did not permit multiple ratings on cables with 2592, was recently revised to permit Class 2, Class 3 cables to also be surface printed as low voltage LED cables. This way, the wire can be used in both 600-volt applications and power-limited applications. UL 4703, the standard for photovoltaic wires. The first edition was published in September 30th, 2014. The changes from the previous outline of investigation included the removal of SBR, IRR, and NR type insulations. It deleted the use of EC-1350 aluminum alloy. It added additional insulation and jacket combinations. It allows single conductor, non-jacketed constructions, and added an optional -50 and -60 ratings. There's no industry review necessary, as these constructions were deleted from the outline investigation, so it did not affect anyone's UL listings. UL 1581, this is a test reference standard. Many of the UL wiring cable standards use 1581 as a reference, and the fourth edition was dated October 31st, 2001, and had revised pages dated August 8th. And this added new requirements for 300-degree C-rated epitaxial co-crystallized alloy and perfluoropolymer insulations and jackets for appliance wiring material. There was a proposal to delete carbon arc weatherometer test and only permit xenon arc. This was something that we no longer support the carbon arc weatherometer test. It's an option if people still want to use it, but it was decided to propose to remove it from UL 1581. And that's the test apparatus that is used to evaluate the UV properties of the jacket and insulation of a cable. Subject 2882. This is a UL 2882 outline of investigation for radio head cables. These cables provide power, data, and signal from a base station to remote radio heads on a tower or rooftop. The first issue of the outline was published October 29th, 2014, and it covers multiple conductor 18 to 4 AWG sunlight resistant, multiple voltage rated radio head cable with different temperature ratings, also wet rating, for supplying power, data, and signal from the base station to the remote radio heads. Revisions to harmonized standards. There are a small number of UL standards that are harmonized with other standards. Harmonized could be the requirements are similar in standards in U.S. and Canada and Mexico, and it also could be binational standards where the requirements are the same. So UL 44 and UL 83, the standards for thermoset and thermoplastic insulated wires and cables, was revised to add SIW conductors to clarify that the requirements that are in the standard pertained to these conductor constructions. Also, in 2014, the National Electrical Code was revised to increase the voltage rating for cables for several building wire types. Several studies were done to determine the appropriate requirements, and UL 44 and 83 were revised to include requirements for the 1,000-volt rated cables. As I mentioned before, certification requirement decisions, CRDs, these are decisions that are made to the standard. They're documented and they're published on the UL standards website, similar to any other change to the standard. But in order to help us meet customers' needs, if there's a new type of technology that is available, we're able to make suitable changes to the standard and go ahead and go forward with the certification. So that's what I call certification requirement decisions, or CRDs. And several of these were issued in 2015. Some of them were to UL 62, which is the standard for flexible cords and cables. The first CRD was for SPT-2W. Currently, UL 588, which is the standard for seasonal lighting products, required that motorized products use a minimum of 18 gauge SPT-2 type cable, flexible cord. And the reason for that is these products are used outside, they're abused, there's some mechanical abuse on it, they're abraded, they're used, if anybody uses these products understand the potential misuse. So we wanted a rugged type of insulation on this particular flexible cord. However, in 588, these products have very low current. So the ampacity levels needed for these do not exceed the ampacity required for 20 gauge. But there were no 20 gauge SPT-2W cables. So we made a decision this year to permit a 20 gauge SPT-2W if it meets all the requirements for 20 gauge and all the SPT-2W requirements. In Canada, there's a cable type CXWT. It's interesting, in the U.S., we have CXTW, and it's a big difference in the requirements. But in a lighting string, the conductors are required to be twisted because the single conductors do not have the mechanical strength necessary. So they're required to be twisted with a minimum length of lay. Now, the requirement for CXWT in Canada required that these wires left the cable factory as a twisted pair. Now, in order to assemble the lamp holders to a string and then do all your electrical connections, you would have to unravel the twisted pair, assemble the lamp holders, and then twist them up again. Now, this could damage the wire by twisting and untwisting, so it didn't make sense that it left the wire factory as a single conductor. So a single conductor type CXWT CRD was prepared. It's still required in the end product that the end product lighting string have a twisted pair. But from the flexible cord side, it can be a single wire that leaves the factory. Type LXTW and LXT. These cable types are the same as CXTW that is used in decorative lighting strings, except these are very limited. They're only for use in pre-lit artificial Christmas trees. And since the installation is limited, we can limit the temperature rating to 60 degrees C instead of 105 degrees C. And that's because these are only for use with Christmas trees that use LED technology. And our experience with LEDs is that it does not have the same surface temperatures as incandescent lamps, which is permitted to be 90 degrees C, which is why CXTW has a minimum rating of 105 C. So these cables are permitted for 60 degrees C applications, only for use in LED lighting, and only for use in modular trees. We also introduced an LXT, which is an indoor version of LXTW. Grounding conductors in EV cables. When electrical vehicle cords were added to UL 62, which is the standard for flexible cords, in sizes above 2 gauge, the size of the grounding conductor was not addressed. So the size of the grounding conductors proposed was based on ampacity values that's specified in the National Electrical Code, Table 400.5 A2 and 250.122. Now, the requirements for grounding conductor for use with 9 gauge were added and permits the use of a smaller 10 AWG grounding conductor. UL 444, the standard for telecommunications cables. A CRD was written September 15, 2015, to introduce a limited power cable. What is shown on the screen right now is the requirements for -LP cables. These cables are tested in a reasonable, what was considered as a reasonable worst case scenario. These cables are 4-pair cables, and 192 cables are placed in a bundle in a Schedule 40 PVC conduit. The conduit has fire stop on each end, and the test setup is that all 8 conductors are carrying the LP rating. So if the rating is 0.5 amps, all conductors in the cables carry the 0.5 amps. And the requirement is that the temperature is measured on the insulation and the jacket, and these cables are measured at the center of the bundle inside the conduit. So the innermost conductor is actually measured, and the jacket and insulation cannot exceed the temperature rating of the cable. And on top of that, temperatures are corrected to an ambient of 45 degrees C. Currently, the applicable cable types are communication cables that are outlined in 444, which is CMP, CMR, CMG, and CM. And there's also plans to revise UL 13 to have the same rating for CL type cables. Now, the optional cable marking is LP in the brackets XXA. Originally, we just had it as XX, but there was some confusion, so we added the A, and it could be 0.5 all the way through 1.0 A, which is 1.0 amperes. And an example of the surface marking is shown below, which is CMP-LP 0.8 A. Then it would have UL, the size of the conductor, and the temperature rating. An LP cable, the data that was obtained through extensive research showed that cable heating can be managed in many ways. One of the ways was seemingly obvious that you have a different size conductor, you can manage the cable heating. The other thing that we found was that cable design variations can also affect the heating of the cable. And the material selection and installation practices can also have an effect. How these cables are installed and the materials used, which would give them a different rating, temperature rating, and can give a larger or higher LP rating. Now, LP cable permits taking advantage of the cable design and innovations, and permits cable manufacturers to design their own products to meet these requirements. It's an alternative to following an opacity table. It's an additional optional rating that may be added to traditional cables. It's not required for new or legacy installations. It's not a mandatory replacement for existing LAN cables. It's just intended to provide another choice for new installations or upgrades, or to address the needs of industry when using cables at these higher current ratings. Materials and compounds. We talked about UL 444 and UL 83, thermoset and thermoplastic cables. Now, all thermoset compounds currently covered in UL online resource will, at the manufacturer's request and after completion of the required testing, be transferred to QMTT2. Now, these thermoplastic compounds used in the end product wire and cable products require long-term tests for the certification, such as sunlight resistance or long-term insulation resistance, which are covered on the category QMTT2. Users of these compounds have the assurance that UL's FUS program is monitoring the ongoing compliance of the compounds and is not changing UL confirms that the composition of these compounds is not changing by performing identification tests also known as our fingerprint tests for these compounds under UL's FUS test program. Additionally, the FUS program on the finished cable provides a supplemental means of verifying ongoing compliance with these requirements. The title of the slide says bulletin compounds, and these compounds at one point were in a paper bulletin, and now you can find them on the wiring and cable website, but they were not subjected to the FUS program as typical QMTT compounds. So thermoset plastics compounds will now be covered on the QMTT2 rather than on this resource or bulletin list. This will give users of the compounds the same level of confidence as a user of thermoplastic compounds. Manufacturers of these compounds currently on the bulletin list will be requested to open new work projects for those compounds that they'd like to have relocated to QMTT2. Samples of the compound will need to be provided in pellet or powder form, and if the compounds are provided in more than one component, they will need to be milled together at the recommended time and temperature. These compounds will be submitted for identification tests, shall be the same formulation as those that were originally submitted for inclusion on the list, and the compounds will be subjected for the fingerprint testing. This will assist manufacturers of these cables in locating the compounds in a documented UL QMTT2 compound categories. In February 2015, UL sent an announcement bulletin announcing the category of acid gas, acidity, conductivity of combustion materials, and assessment of halogens. These are evaluated in accordance with the UL's outline of investigation, UL 2885. And this is a compound. This is where the compounds are submitted to determine whether or not there's acid gas or halogens and the conductivity of combustion materials. There are two subscribers that have UL recognition under the CCN AATJ2, and it can be used for manufacturers of any wiring cable. It's an optional add-on to current categories, compound categories, consisting of QMTT2, QMTN2, and QMTM2. Now, the scope of 2085 cover tests and evaluations for assessment of halogens for individual combustible materials used in wiring cable. So if there's a binder jacket, there's a jacket, insulation, these are all individual combustible materials. So anything inside the cable construction that can combust would be a material that could be assessed under this category. The requirements do not cover assessment of combined components of the cable construction. This is only the materials, is not the cable. And it does not investigate other properties of materials, including flammability, toxicity, or environmental risks as described in IEC 62821-1 and 62821-2. There's a four-step protocol used to determine the halogen-free content for these these components, including the insulation fillers, jackets, tapes, etc. And the first stage, or stage 0, is sodium fusion. Stage 1 would be pH and conductivity. Stage 2 would be the bromine and chlorine content. And stage 3 would be the fluorine content. Now, if a cable manufacturer wants to use these materials, there's an option for cable manufacturers called halogen-free HF and low-smoke halogen-free LSHF optional surface marks. This is where the complete product, a complete cable, is tested in accordance with the IEC standard for smoke generation properties. It's used for complete wire and cable constructions. It's under existing wire and cable CCNs. For example, on the DUZX, there is an LSHF rated cable. It's used in conjunction with revised outline investigation, which is 2885, and like I said, it's an optional add-on for CMR, CM, etc. You could have LSHF or -HF. And the announcement bulletin was the same announcement bulletin where we announced the compound program. This is a picture of the apparatus that's used to measure the smoke, determine if it meets the LS portion of the LSHF, and this is in accordance with IEC 62821-3. Thank you very much for listening, and thank you for your time.
And thank you, Anthony. Yeah, thank you, Anthony. And at this time, we have received a number of questions. We're going to handle questions as time permits. And we do want to conclude this presentation at about 11:15. But in the meantime, we will take some questions. Anthony, I will be presenting these on behalf of listeners as they came in. I would like to start with the first two questions are more or less related. One was a little bit generic, one specific, but I'll start with question one and question two from the listeners. Is testing certification at UL in the U.S. acceptable in Mexico or Canada? And another listener just was kind of saying the same thing, only asking for more details. For harmonized standards between the USA, Mexico, and Canada, can you get your listings / certifications in one country and have it be acceptable in other countries, so to avoid duplicate costs and certifications in each country?
Yes, and for harmonized standard, like UL 444 is a binational standard. UL mark, we have a mark for use in Canada and the US. So you could test your telecommunications cable to UL 444, and that will be suitable for certification in the US and Canada. For Mexico, if there's a memorandum of understanding, then we'll be able to have one investigation for US and Mexico. But typically, you know, that's very limited. If we have a specific category, if somebody wants to submit, we'd be happy to help them with that.
Okay. I'm going to continue with questions, and we'll remind listeners again that if your question was answered, great. If you wish further clarification, we will be providing contact details at the conclusion. Next question, Anthony. When submitting cables to UL safety listings to UL 1685 tray, UL 1666 riser, and NFPA 262 plenum, can UL also provide the listings for FT-2, FT-4, FT-5, or FT-6 cable ratings for Canada? Are they or are they not virtually the same as the NEC requirements?
Yeah, that's a multiple level question. So as far as plenum, we have permitted the FT6 marking for CMP cables. So cables that have the plenum certification, they're permitted to have the FT6 marking on the cable as well. 1685, there's two tests in there for tray cable, and one is FT4 and the other one is the UL cable tray test. And the 1685 cable tray test does not represent FT4. So you'd have to specifically have the cable tested to FT4. Now in Canada, the riser cables do not follow 1666. At least in the optical fiber cable world, they are required to be an FT4 rating. So the riser requirements in Canada in the Canadian Electrical Code are different than those specified in the National Electrical Code. So there's three different questions built into that one question, and I hope I answered them all.
Okay. And then another question, which I believe is somewhat related to what you just said. What is the FT5 flame rating is the cable fire performance testing vertical, like FT4, or horizontal, like FT6? And what are the pass-fail criteria?
I'm not personally familiar with FT5 because in the telecommunication cable world, we don't specify that in the U.S. or Canada. So we have the information, and we can provide a response separately to the person who had that question.
Okay, great. Yes. Listeners, if you ask that question, please follow the contact criteria. Next question. Do the new LP optional cable safety listings as proposed in the UL 444 CRD also apply to Class 2 or Class 3 circuit cables per the National Electric Code Article 725?
Yeah, we are in the process of preparing a CRD for UL 13, as I mentioned in the presentation, for CL2 and CL3 cables. Those are the cables that are in the Class 2 or Class 3 circuit. So we have plans on publishing that shortly. Currently, we haven't had a submittal, so it hasn't pushed us to move forward with that as quickly as we did for UL 444 CRDs. But we are in the process of doing that right now.
Okay. And we have one final question that has come in at this point, and that is, what, if any, UL standards are available for the frequency-dependent complex permittivity measurement of data cable dielectrics?
That seems like a very specific question, and I'd be happy to work with the person that submitted that question on a separate basis, separately.
Okay.
I need to have a little bit more detail in that question.
Great. Okay, Anthony. I remind the listener who proposed that question, go ahead and be in contact. At this point, I don't have any further questions, Anthony. So what I would like to do is thank you for presenting this very interesting and important topic today. Again, this paper is available as paper 15-2 on the archives page of the IWCS.org website under the 2015 tab. Please note the contact points being shown should you wish to contact Anthony after today's event. Each of these IWCS webinar series presentation events are recorded and will be archived on the IWCS.org website. It normally takes up to 2 weeks for these to be posted. The IWCS webinar series will conduct presentation events on a monthly basis. Webinar events will take place on the third Friday of each month at 10:30 a.m. Eastern USA time. Our next scheduled webinar event will be on Friday, December 18th at 10:30 a.m. Eastern time. Each of you will be receiving an announcement for the event a few weeks prior. Please feel free to share our announcements with your colleagues so that they can join in and register as well. For over 60 years, the IWCS International Cable and Connectivity Symposium has been the recognized leader showcasing new technologies in cable and connectivity products, processes, and applications. Our next annual conference will take place on Sunday, October 2 through 5, 2016 in Providence, Rhode Island. Please visit our website at IWCS.org for more event details. In just a moment, you will see a brief survey so that you can provide us your feedback and comments on today's event so that we can further improve this webinar series for you. Thank you for participating, and this concludes today's event.